PDF notes lah. I just convert it to Excel notes lah. Okay, so for example, so first thing is you need to know what is supervised learning. So in data science, for example, let's say if you have your data, so let's say it doesn't matter either your data comes from secondary storage, secondary sources or primary sources. So once you have cleaned your data, and then at the end you want to do the analysis, right? So for example, let's say if you want to predict the customer behavior. So before you can predict the customer behavior of buying products, of course you must have all the information or all the data set, for example. So you can gather data about the location or the age of the customer, or maybe you can measure, you can collect their gender, or maybe you can also collect their family status, and also their lifestyle, for example. So assuming that you work as a data scientist or data analyst, and then you want to identify their buying behavior of buying a certain products because you want to make promotions in order to increase your sales lah. Okay, so you can collect all this data set, and then once you have collect this data set, of course you want to process it lah. Okay, so after you process it, so there are many ways that you can identify their behavior. So the standard techniques to identify their behavior is assuming that you already an expert of this transaction. Okay, so based on your expertise, so you can easily predict their behavior of buying something. One thing, because you are expert. Okay, and then the second way to predict their behavior is by using statistical techniques. So okay, and we have another technique. So this technique under scientific techniques, what we call it as machine learning techniques. So machine learning is it is just like you give this data set, and then the machine learning will learn the data patterns automatically. Okay. So under machine learning, so we can divide it into supervised and also unsupervised learning. But somehow, actually, we have a lot of learning algorithms. For example, we have semi-supervised, reinforcement learning, and so on. The one that you use, ChatGPT, right? So ChatGPT is under semi-supervised. Okay, but today we want to focus on supervised learning. Okay, so under supervised learning, so we can divide it into two parts, which is classification and also recreation. So how to identify, either you can do classification or regression based on your data set. So assuming that you have a data set lah, and then you want to do supervised learning, but somehow you are not sure either you are working with classification or regression. So first and foremost, you need to identify which tasks that you need to do based on the data set. So for example, so assuming that this is your data set, so we have var1, var2, var3, variable 3, variable 4, and also the result. Okay, so it means we have 1, 2, 3, 4, 5 columns. So this column is what we call as features or attribute. So for example, so if you look at here, var1 up until var4 is what we call as input features. And also result is referring to the output features. Output feature, one output. In programming, we always denote the input features as X, while for the output feature, we denote it as Y. But somehow, if you want to use another symbol, also can. So it depends on you lah. Okay, so based on these 5 columns, so we can see that the output feature actually is a dependent variable. And then var1 up until var4 is independent to each other. Independent variable. Okay, so in order to create the output feature, which is the dependent variable, so we need to check var1 values, var2, var3, and also var4 lah. So that's why we call it as dependent variable. So it must depends on another variable's values. Okay, so this one feature, right? So another name for the feature also, for example, let's say if you are doing your assignments, right, and then you want to search online for any informations, any extra information. Some of the papers or researchers, so they don't call it as features, so they call it as attribute. Also same. Okay, and then based on this data set, we have 1, 2, 3, 4, 5 records. Some of the papers, they don't call it as records, but they call it as tuples or instances. So actually it refers to the same thing. Attribute, features, variables. In mathematics we call it variables, right? Same thing actually. Okay, now how you can identify either your data set here, so it belongs to classification or prediction. So next we need to check this part. We need to check the output feature part. So for example, if based on this output feature, it contains a categorical data in category, so you can use it for classification. If in under the output feature, it contains continuous values, continuous variables, like maybe the ringgit lah, the price, ringgit, 2 ringgit and 30 cents. So this one is continuous variable. So you can use this data set for regression. It is just like your assignment. Some of the data set you can use for both classification and also regression. Some of the data set you can only use one only. Either you can only handle classification or regression problems. If in your data set you have multiple problems to be solved, so you can choose one only lah. Okay, so this one is another example of classification and regression. So for example here, okay, so assuming that you want to predict the temperature for tomorrow. Okay, so temperature is assuming that the temperature is 84 Fahrenheit lah. Okay, so this one, because the output feature is continuous, so it falls under regression problems. Okay, and then so we are referring to the same temperature event. So instead of measuring the exact values, so you want to classify it, either it is gonna be cold or hot tomorrow. So in this case, cold and also hot actually is the categorical. Regression, the value, the continuous value, and classification, categorical. Or maybe you want to group something accordingly, maybe a group A, group B, group C, and so on. So that one also under categorical. Okay, and then if you look at here, so instead of using machine learning method or algorithms to predict the temperature and also to classify the temperature, either it is cold or hot, so we also have the existing approach or existing techniques that you can use to handle this regression and also classification. So one of the methods is what we call as statistical method. Okay, so for example, statistical method, so we have ARIMA, ARMA, and so on. So this statistical method, it makes use of all the equations, formulas, and so on. But somehow, because of this data set actually, so it appears it contains fluctuations. For example, we have the values which is ups and downs, and also it might be affected by seasonal factors like flash flood, and also might involve other event like maybe earthquake and so on. So it cannot handle non-linearity. So this phenomena like earthquake and also flash flood is what we call as non-linearity lah. And also, for example, like natural phenomena, earthquake, quake, what else? Flash flood, and so on lah. Okay, So this is the limitation of using statistical methods. Okay, so because of this limitation, so we want to use machine learning method. Okay, so another reason why we prefer to use machine learning method is just now I mentioned that in order to do regression and also in order to do classification, you can also interview the experts, isn't it? Okay, so when we talk about experts, so of course it contains a kind of event that we call it as rules. Okay, so for example, in order to identify either the weather is cold or hot, so we need to provide the rules. Okay, so this rule must be written by the expert. For example, in geology field and so on. So when we talk about rules, so this is the sample rules. Rules means we are dealing with if then cases. So for example, so assuming that we have maybe we have 5 input feature, 5 criteria or 5 features, and then we want to identify either it is cold or hot tomorrow. So I create rules lah, a set of rules. So for example, if temperature let's say those 5 feature is yes. Okay, list down 5 features to predict to classify cold and hot. Jot down lah. Come here, come here.
왜? 너랑
Okay, so for example, let's say if you want to identify the temperature it belongs to cool group or hot group, so assuming that we have 5 features lah. So we have relative humidity, we have light intensity, ultraviolet index, and also wind speed, and also time of the day. Okay, so if you are using the ordinary rules that involve if then rules, so you need to consider these 5 features in order to create your if then rule. So for example, so you need to list down all the possible probabilities lah. So for example, if humidity is high, and light intensity is high. So these are only 2, right? So we add another n, and UV index maybe is equal to 2.0. Okay, and then you create another n statement. Wind speed is maybe 25 degree, and time of the day is morning, for example. Then you can create the consequence lah. Then the air temperature, humidity high, is hot. So this one only one rule, but just now I mentioned that you need to create or you need to list down all possible rules. So based on this 1, 2, 3, 4, 5 features, so you need to, so there will be cases that you might need to create hundreds or thousands of rules. So it will take time, and it also can be done by the expert actually. Okay, so we don't want this part actually. We don't want to create all the so-called all the long rules, don't want. So that's why you can use machine learning. So this is the reason why we use machine learning, in order to do classification or in order to do regression. Okay. Okay, and then in machine learning, just now I mentioned that we can divide it into supervised and also unsupervised. Okay, so under supervised, we also have another 2 tasks. Just now I mentioned that we have classification and also regression problems, which is regression should focus on the continuous variables values, and classification should focus on the categorical variables values. Okay, so if you want to use machine learning algorithms or method to handle classification problems, so you can use linear regression, or you can even use k nearest neighbor. You can use support vector machine, so you can use a decision tree, you can even use artificial neural network. So your ChatGPT is developed by using artificial neural networks, variants of artificial neural networks called deep learning actually. Okay, and then for regression problems, so you can use logistic regression machine learning model. Regression. So some of the machine learning models also you can use it for classification and also regression. So for example, and also you can use it for handling the regression problem. So same goes to SVM. If you do your Python code, so if you want to focus on regression, you can opt for support vector regressor. If you want to use SVM for classification, you can use support vector classifier. So both support vector classifier and also support vector regressor, it is under parent SVM lah, support vector machine. Okay, and then so you can also use a decision tree and artificial neural network. So one of the most well-known or robust artificial neural networks is what we call as multi-layer perceptron. Okay, or we call it as MLP. So this one is the ordinary module that falls under neural network lah. MLP. So MLP also you can use for classification and also regression. Okay, and then now we focus on this part first. Linear regression. Sorry, logistic regression. Linear. Okay. Linear regression. So this one is from your notes actually. So how actually your linear regression works. So you can calculate the linear regression by using this least square estimation method. So linear regression actually was one of the statistical techniques. Under regression, just I mentioned that we have logistic regression, linear regression, and also we have another regression algorithm called multilinear regression. So what does it mean by linear regression is, so that means we have single predictor. So single predictor here means we only have one input feature. So if you have one input feature and you want to predict the output feature, or you want to identify the class label, so you can use linear regression. So that means we want to measure the relationship between the variable x and also the variable y. So when we talk about two variables, the relationship of two variables, so that means if you want to express it in the form of graphs, so you can draw a graph like this lah. So y-axis is referred to the feature value or the single predictor values, and then y value here is referring to the class label. Okay, so we want to identify this one. Okay, and then if you have multiple variables, so for example, based on this data set, we have 4 variables. Okay, and then you want to get the result, or you want to do classification or regression. So this is the implementation of the multiple predictors lah. Okay, so based on the values of variable 1, 2, 3, and 4, so we want to get the final output. Okay, now we want to use the linear regression. So just now I mentioned that you can use least square estimation method. So how it works? So this is the step-by-step process. So assuming that we have these 3 columns, and then the first column indicates the user ID. Normally in classification and also regression, because it is supervised learning, usually we ignore this part, because the user is only the identifier. It does not contribute to the patterns and also the behavior. So in this case, we want to identify the relationship between the number of friends and also the time spent. So how to identify? Just now I mentioned that you can use the least square estimation method. Okay, so assuming that this is your graph, and then the y-axis is referring to the number of friends, and then y-axis indicates the number time spent. Okay, so you plot each data point to your graph. Okay, and then once you have plotted the data point accordingly, and of course you need to start drawing the lines. So this line is what we call as regression line. Okay, for example, let's say after I plot, so I draw the regression line maybe somewhere here lah. So we want to identify either each data point is nearer to the regression line or not. Okay, so if it is nearer to the regression lines, or if it is compact to the regression lines, that means number of friends and also time spent is related to each other. So that means it has a strong association or strong correlation. If you're using Python, so Python will automatically draw this line for you. If you're using the statistical methods or any other programming language, you need to use trial and error lah. For example, first round, so you can draw maybe the regression line should be here, but somehow the data point is scattered a bit lah. Then you start redraw the next line and see what is the trend. Either the data point is nearer to each other or not, nearer to the regression line or not. Okay, so our aim for linear regression is we want to capture the best line, the best regression line. So in this case, you need to identify what is the slope and also what is the y-intercept. So by using least square estimation method. So this one I think you have learned in your statistics. Must explain lah. Okay, assuming that this is the values for the x and also y values lah. Okay, sample only ah. So this one is different from number of friends just now. So assuming that this is the x value and also y value. So x value is from 1 up until 7, and then this is the y values. So once you have get your data set or data point, okay, and then you need to calculate the total summation of x here. So total summation of x. So in this case, total summation of x is equal to 28. Correct or not? 1 plus 2 plus 3 plus 4, 5, 6, 8 is 28. Correct? Right? 28, right? 28. Okay, and then, so once we have calculate the total summation of x, and then you need to calculate the value of y. So total value of y is 61.8. So this one, 1 plus 1.5 plus 3.8 plus 6.7 plus 9 plus 11.2 plus 30.6 and also plus 60. So you will get 61.8. So based on this value. Okay, and then you need to calculate the summation of x multiplied by y. So you will get this value. Okay, and then x squared, this value. So this is total for each column, each records lah. So x, summation of x, summation of y, summation of x multiplied by y, and also summation of x squared. Okay. Okay, and then after that, so what is the next step? So you need to calculate the slope, actually, the m values. So what is the formula of m values? So this one is standard equation, right? So you use the equation, then you need to find the m values here. So this is the formula to calculate the m values. So you just replace the values that we have calculated previously. So you will get okay, 2.4214. Okay, 2.4214. Okay, and then this is your latest equation. Okay, so instead of using 4 floating numbers, so this one, so y is equal to 2.4214 x plus c. So x plus c. So now, after we have identified the m values, then you want to identify the c values lah. Okay, so how you can identify the c values? So this is the formula. Okay, so you just replace the values that you have calculated previously, and then we will get the values. Value is negative 0.857029, and then we convert it into two floating numbers lah for simplicity. Okay, so this is your linear regression equation. Okay, so this is your linear regression. Okay, and then for example, we have another calculations here. So based on these equations, right? Based on these linear equations, and then you can replace the values of x, either it is near to your values or not, to your actual values or not. So this part. Your equation. Okay, and then for example, you want to replace x with the values of 2. So so 2.42 times 2 and then minus 0.86, so we will get 3.98. So but in this case, so the actual values is 3.8. So 3.8 compared to 3.98, actually it is quite the regression or the deviation is a bit small, so we can accept this linear regression actually. So you can also try with another value. So for example, let's say you want to replace the x with 4. Okay, so you can start calculating. So y here is referring to the actual values. And then after you replace x, so the predicted value is 8.8. So 8.8 we compare with 9, consider as okay, so the deviation is a bit small. So in this case also we will accept this formula. So this is how we can calculate the linear regression by using least square estimation method. So this one is just flashback. So I think you have learned this in your statistics, right? SPM. Calculate the y-intercept lah, to calculate the slope and so on. Okay. So this formula actually is needed for us to identify what is the best fit line actually. So we want the deviation, we want to the deviation between the actual and also the predicted as small as we can. So you can use this method. Okay, and then next we proceed with KNN, K nearest neighbor. So K nearest neighbor, so assuming that you have a data set and then you want to identify the new data set, actually it belongs to which class. Okay, so for example, based on this data set, you want to identify what if a new guy is 57 years old and makes 30,000 ringgit monthly. Okay, so assuming that this new data set, so it belongs to somewhere here. So in this case, we have the opaque circle, green circle, which indicates as one class, and then the colorless green circle is considered as another class. So we want to identify either this data set actually belongs to class 1 or class 2. So in order to do that, so you can also use K nearest neighbor. So K nearest neighbor works is by identifying the K values. So the standard K values that has been used by many developer or many researcher is 3, 5 and also 10. Okay, so for example, so assuming that, so this star indicates the new data point and then you want to identify either it belongs to class A or class B. Just now I mentioned that first thing is you need to set the K value. Okay, let's say I set the K value to 3. And then, so 3 here means 3 neighboring data point. 3 nearest data point to the new data point star. So in this case, we draw the circle like this. Either you can use these tools, or you can even use the measuring. You can also measure the distance by using Manhattan distance and also Euclidean distance. Okay, so based on this K is equal to 3, so we found out that So in these circles, so 2 data points actually belongs to class B. Okay, so in this case, this man, which is X here, so it belongs to class B. So K is for you to decide. Okay, and also maybe you want to try another K value. So for example, 6. Okay, and then you choose 6 neighboring data points that is nearer to your star data point. So in this case, we have 1, 2, 3, 4, 5, 6 data point. And then based on K is equal to 6, we observe that we have 4 data point that is belongs to class B. So in this case, when K is equal to 6, so star here actually belongs to class A. So that is how the KNN works lah. So you will need to identify the K values. Okay, we have another examples like this. So you need to identify, you need to compute what is the probability of X here. Yeah, what is the probability of your star here? So actually it belongs to class dog, class cat, or class bird. So based on this data point, we have 3 different classes: circle, triangle, and also diamond. So for example, you want to calculate the X, the probability of X belongs to class dog. So you calculate lah. So dog, in this circle we have 1, 2, 3, 4. P dot X 4, and then total number of every data point in your circle, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 4 over 9. P dot. Okay, and then probability of star or X belongs to cat classes. So we have 1, 2, 3 cats. 3 over 9 or 1 over 3. Okay, and then for P, the probability of X belongs to bird, diamond. 1, 2, 2 over 9. Question? Okay, and then based on dog, cat, and also bird, so you need to identify which class that X belongs to with explanation. So what is your conclusion? So X belongs to which class? Dog. Why? Why? Highest probabilities lah. Compared to dog, compared to cat, and also bird. So this one is a simple question. So we proceed to more challenging questions that involve the calculations of distance by using Manhattan and also Euclidean distance to identify the nearest neighbor. So Euclidean distance is we want to measure the straight line between one point and another point. So it involves the coordinate of x and y, the x coordinate and also the y coordinate lah. Euclidean distance, straight line. And Manhattan distance, it measures the distance between two lines by considering the distance, the horizontal distance, and also the vertical distance. So another name for Manhattan distance, also we call it as taxicab distance. Euclidean distance, straight line, and also Manhattan distance is we measure the vertical and also horizontal line. So this is the formula, and then you need to expand these formulas. So how you can use this formula to calculate the distance. So assuming that we have 1, 2, 3, 4 columns, and then you want to identify the Euclidean distance. We have 1, 2, 3, 4, 5 records. 1, 2, 3, 4, 5 records. Okay, and then based on these 5 records, we have another new records, which is Monica. So this is the height of Monica, which is 161 cm and also 61 kilogram. Okay, so we want to identify either Monica, actually it belongs to which class of t-shirt size. So first thing is you need to you need to calculate the distance between Monica details with Alice, with Bob, Carol, David, and also Emily. So you need to calculate it. So based on this Euclidean distance formula, so we calculate lah. So 161 here is referred to the x value of Monica. So assuming that this one is x, and then this one is y values lah. Okay, so Monica x, Monica, and 165 is referred to this values. Okay, so x2 minus x1, y2 minus y1, minus x1 squared plus y2 minus y1 squared, and then this one after we expand this formula. Okay, and then Monica 161 height, and then minus 165 is referring to the Alice height, and then squared plus 61 is referred to the Monica's weight. In this case we call it as y value. This one is the x value. Okay, so we will get approximately 4.12. So this is the distance. And then Alice finished already. Okay, and then we want to calculate the distance between Monica to Bob. And then we replace the values in these equations to the values for Bob. So 161 is referred to the Monica's height, and 175 here is referring to the Bob's height, which is the x values, plus 61 is here, minus 80, so 80 is here, so you will get 21.40. And then you need to calculate all the distance between Monica to Carol, David, and also Emily. So this is the result lah. So this is the value. Okay, so assuming that, so you set the k value is equal to 3. So we need to check based on the distance. So we need to check lah. So in this case, we will take out 3 values of Euclidean distance, which is the nearest neighbor. So in this case, the nearest value is this one, this one, and also this one. Alice, Carol, and also Emily, when K is equal to 3. So in this case, based on Monica's height and also weight, so actually Monica, she belongs to class M. T-shirt size class M. So instead of using Euclidean distance to calculate the shortest distance, you can also use Manhattan distance. So this is the formula. Plus minus y1. So you replace these values. So x2 here is referring to the Monica's height, minus 165 is referring to the Alice height, plus y2 Monica's weight, and then minus 60. So 60 is the Alice weight. So you will get 5. So you will use the same formula and then you calculate the distance from Monica to Bob, Carol, David, and also Emily. So you will get this result. So assuming that I set the K value is equal to 3, then we calculate the shortest distance. Shortest distance by using Manhattan. This one, and also this one. Alice, Bob, Alice, Carol, and also Emily. Same. Alice, Carol, and also Emily. So in this case, when we set the K value is equal to 3, so Monica's, she belongs to the shirt size of M. And last. So this one is the expansion of this one, right? Am I right? Correctly or wrongly? Wrong. Okay, so this formula will not be given during your final. So I don't know. For this example, they only give you two values, isn't it? Height and also weight. So that may be cases you need to calculate the exact values. Exact values, then you need to expand like this. Plus Z2 minus Z1. Can we proceed? Okay, so last one. Neural network, artificial neural network. So this is the diagram of artificial neural networks. So actually it is inspired by the human brain. So yourself, so how we are going to translate, or we want to transmit the data so that it will become the information. So for example, like you hold pen, and then what you are going to do with the pen. So from your hand, your hand will send the signals, and this signal will be transmitted to your brain. So this is how it works lah. So in this brain connection, so this uh, area is what we call as dendrite, and then we have the nucleus or the main uh, 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 what nucleus is referring to the main to the information that being processed, and then this is the cell's body and also axon, and then the last one we have the axon terminal. So in this case, from this biological neuron, so we will use this diagram to create the neuron. Okay, so this single neuron is what we call as perceptron. Single perceptron. So just now I mentioned that in neural network you have multi-layer perceptron, right? So before multi-layer perceptron is introduced, first thing is they create this single perceptron first. So this single perceptron, it is based on your biological neurons. So for example, if you are talking about neural network, so you must have the input. Standard, the ordinary perceptron, we only have two parts, which is the input and also the output. So like this, input and also output. So what does input and output mean? So if you have a table, so input here means input features. Output here means output features. Feature. Single perceptron, we only have input features and also output feature lah. But somehow they expand this single perceptron by creating multi-layer perceptron. So just like the name, multi-layer perceptron, MLP. So we have the input layer, hidden layer and also the output layer. Okay, so the input layer will contain the input features. Okay, input layer will contain input features. So for example, let's say if you have 20 input features in your table, in your data set, so that means you need to create 20 circles. So this circle is what we call as neuron, because it is inspired by the brain, right? So we call this circle as neuron or node. So all this circle is what we call as neurons or nodes. Okay, so how to identify each node? So if this node is located at the input layer part, so we call it as input node or input neuron. Input layer part, right? Input layer, hidden layer and output layer. If your circle here or your neuron here it is part under hidden layer parts, hidden layer area, so we call it as hidden node or hidden neuron. So same goes to the output layer. So in this case we have two nodes. So this one is what we call as output node of neuron. Okay, single perceptron we only have input and output. Multi-layer perceptron we have another layer called hidden layer. So hidden layer will carry all the information. It is just like how your brain process all the informations lah. So instead of you are having pen, and then if you are talking about reflex connection, so it only involve the input and also the output. But somehow, if you have pen and then you need to think what you are going to do with that pen, so the thinking process actually it belongs to the hidden layer parts. So your brain will process what you are going to do with the pen actually. and then at the end it will send the notification back to your hand, and then later on you will decide what you are going to do with that pen. That's the output. Input, data, and the hidden layer is how your brain works, and output is the outcome, what you're going to do with the data to create information. Okay, so we go back to your input layer. So let's assuming that in your data set you have 20 input features. So in that case, you need to create 20 nodes actually. For your iris data, you only have 4 input features, isn't it? So you need to create 4 nodes. So each node will represent the input features. Okay, and then so we KIV for the hidden layer part first, and then we proceed with output layer. So output layer, how to identify how many output nodes that you want to draw. So output nodes here is referring to the output feature. So for example, let's say if you are working with classification, and then you want to classify the iris according to 3 class, which is iris, setosa, vehinica, and also vehicular, right? Vehicular. Okay, and then in this case, you might have 3 output nodes. Output layer, we follow the number of class in the output features. Okay, and then hidden layer, you can have you can have as many layers that you want, but normally we only use 1 layer only. The complexity lah. So more complex you process information, sometimes it is better, but somehow it is also advisable for you to keep it the hidden layer as simple as you can lah. So for example, so in this case, we always draw 1 hidden layer. So in this example, we have 1, 2, 3 hidden layers, but somehow 1 is already enough actually. So how to identify the numbers of hidden nodes in hidden layer is you can follow this formula. 2 to the power of n. So 2 here, 2 lah. So n here is referring to the number of input nodes. So for example, you have 2 to the power of 4. What is the answer? 16. So the maximum hidden node is 16 if you have 4 input nodes. So you can start drawing. Minimum number of hidden nodes is 2 to 16 for the hidden nodes in hidden layer. So the calculation we continue next week, but I want you to draw the architecture. So this diagram, we call it as neural network architecture. Artificial neural network architecture. So I forgot to tell you something. So if you see here, we have 1 straight line, so that connects the input node, so the hidden layer, from hidden layer to another hidden layer, and from hidden layer to the output layer. So these lines, we call it as widths. Okay, so in labeling, so we always note it as width ij. Width from input node I to j. So in this case, node j, n. Width I to n, because h is equal to n here lah. and then here is another weight from N to O. How you write? So input layer X. Okay, let's say hidden layer H1, 2, H3. Output layer O lah. O. Okay. So weights from input layer Xi to hidden layer. So we always write it as weights I to N. Mathematics. Okay, so you want to label, right? For labeling purpose, wait lah. So from I to N. So I here is referring to I here. N here is referring to this one. Hn. From I to N. Okay, and then we have another weight here from the hidden layer Hn to O lah, for example. So weight from hidden layer N until output O. So this is how you label the weights lah. So what if let's say I have weight Wij? So what does it mean? Weight from input I to J. From I to J. Weight WEIGHT. Okay, so this is how you label lah. For labeling. Okay, and then question. No, I'm going to ask you a question. Okay, so can you see this table? So I think I want to which one this one first lah. I give you one example and then you draw the architecture of neural network for me lah. Okay, and then so based on this table 2, 1, 2, 3, 4, 5 columns or features. So assuming that the output feature actually is the by computers. So this one is the output features. And then in this case we have 1, 2, 3, 4 input features. Okay, and then you want to draw the neural network architecture. So you must have input, hidden layer, and also output layer. So we start with input feature first. So because we have 5 input features, then you will need to create 5 nodes. So this one input feature, input xi, input xi. Okay, and then hidden layer we get first, and then for the output layer, output layer. Since based on this we have 2 category only, which is yes and no. So for the output layer, so assuming I put it as O K lah, 1 and 2. So this one is for yes and then this one is for no. So don't forget to label. So this one for age, income, student, credit, rating, and also four only. Okay, so input layer done, output layer done, and then for the middle part, which is the hidden layer. So just now I mentioned that 2 to the power of n is the maximum lah. 2 to the power of 4 is the maximum. So minimum 2 for the hidden layer. So let's say I name the hidden layer as HJ lah. H subscript J. So at least one layer. So and I create 3 nodes lah. Minimum 2 nodes for the hidden layer part. Maximum 16. So for the hidden layer, it doesn't matter as long as it follows from 2 to 16. Okay. So once you have drawn the hidden nodes in your hidden layer, then you need to create your direction arrow or straight line. So all nodes must be connected to each node. So for example, H must be connected to this part. 1, 2, and also 3. Okay, and then for the income also, so it must be connected to the hidden layer nodes. 1. So same goes to the all input nodes must be connected to the hidden nodes in hidden layer. And then the last one is for creative. 1, 2, 3. Okay, and then for the weights for the from hidden layer to output layer, so it must be connected. So from here, 1, 2. And this one. And this one. And this one. So once finished, then you can label your lines or your arrows. So for example, so this one is weight and then this one is also weight, right? So how to differentiate between both weights? So weights from I to J. Weights from J to K. Can we proceed? So I want you to create the neural network, the artificial neural network architecture for this data set. So I want the input feature to be output feature to be the cepat lah. So draw your neural network architecture now. So must label lah. Right, so if for example, so I want to add more thing. If your output feature is under regression, so means continuous value, so you can create one node only lah for the continuous part. one node for the output layer, one output node, if it falls under regression problems. Classification depends on how many class that you have. If you have 5, then 5 nodes, 5 output nodes. So this one.